Amol Padi sir.
हाँ सर.
Amol Padi sir, are you on the line?
Hello.
Yes, sir.
Yes.
Sorry for the interference. This is brief introduction about sir, and we welcome you to the session. And without wasting much time, we request you to take the charge, sir.
Okay, thank you. Okay, then I will share now. One second, I'm sharing now. I don't know, should I share the window or should I share the tab? Or just give me the feedback there once I share it.
Your PPT can share, sir. Kothavale sir, PPT can share.
PPT, yes, I was trying that. See, is it? I think window is coming there.
We can see your screen. We can see
Is
your
it screen is visible?
Screen is visible. Only PPT you can share.
Not visible, sir.
Yes. No. Okay.
Your screen is visible, sir.
Is it
PPT is
visible
visible.
now? Okay. I'm hope now you can see my PPT or PDF. This is PDF I made. PPT is also there. So let us see.
We can see your presentation. We can see your presentation, sir.
Okay. And I'm in hope I am audible also there.
You are audible.
Okay. Thank you. I'm very much thankful for inviting me for sharing my some of these ideas and knowledge with research methodology with you. So I am thankful to the management of Nanasaheb Mahadik College of Engineering, as well as principal Dr. A. Mirja sir, then the course convener, coordinators, and the member who is in contact with me, Mr. Workday. So these are all in touch with me. They are planning for more than 1 month, and this is all the work behind going on, and then we are coming here. So the topic is, I think you have already started from last 2-3 days, and the ice breaking session is already happened. There is a lot of input already has been given there, and then I am coming in the part there where we are discussing about the data, the mathematical modeling and analysis of data. This is the particular core.
आवाज येत नाही सर.
Kotal sir, your voice is not clear. Kotal sir.
You are not audible, sir.
Kotal sir.
Yes, I think somebody muted me. I think that is the problem. When you are muting all, that time speaker also got muted.
Okay. Now you are audible, sir.
Okay. Mhm. Yes, I think, but I can't see now.
You are
Yes.
audible, sir. Kotal
Okay,
sir, you
now
are audible.
the screen is visible.
Visible. Visible. You can start it.
Yes, sir, it is visible.
Some lag is there. I don't know. Okay. The research process, again, I'm coming here. I want to explain only the meaning is that where this particular topic is there. So what we are discussing today, where it falls in the whole research process. So this is already a lot of diagrams might have shared with you about whole research method. But particularly what we are learning today, where it falls, where is the exact place that I want to inform you. And then we'll come to know when we are learning this, actually where it is useful. So I feel that the attendees now, they may be either pursuing research or they may be willing to that. So there you will come to know what we are learning today, where it is useful. This is the typical research process, the defining or identifying the problem, observations, hypothesis, organize the data or the experimentation here. So today's topic comes here when we are collecting the data and when we want to process the data. That time we need to make a mathematical model, especially the research which is belong to the engineering background. We need a mathematical model, and what is use and applications that we are talking. I hope the last slide was not there. A little bit moving fast. I don't know. The lag is here. Something is. So the research may be fundamental research, applied research. Okay. Am I audible? Hello.
Yes, sir.
Okay, and PPT is visible there.
Yes, sir.
Okay. So this is my brief introduction. So earlier they introduced me, so there is no need that. Okay. Outline is what is data, what is modeling, why modeling is required in the research step, then application, various types of modeling and process of modeling that we are discussing. Mathematical modeling and engineering problem solving, that is one we are talking about. And then some analysis, linear, nonlinear analysis, asymptotic analysis, sensitivity analysis, those are required in the research process. So this is the outline for the today's lecture. So this is a takeaway that we are what at the end of lecture. So we should know that what we are learning. So there are three basic questions when I'm learning today or listening this, whether I'm enjoying this lecture or not. What is the gain in knowledge? Okay, that is the second thing that I must know that. And third, how I can use that. So basically beginning with the research, fundamental research, applied research, and development research, these are the three methods. Fundamental research goes in the scientific way, science there. Normally, our engineering research comes under the applied research and development research. I hope all the audience, they are belong to the engineering colleges. Hello. Hello.
Yes, most of the participants are in engineering, some are from other branch also, but most of the majority of the participants are from engineering.
Okay. Then I was coming the same slide here where I can see that where exactly today's topic falls. So this is the particular area we can say our today's topic falls here. This is the typical diagrams which are available on the internet there. And again, the same question is that where exactly today's topic falls. There is some disturbance. I think somebody need to be mute yourself. Hello. Some disturbance is there. If anyone kept your mic is on, you can switch off. So when you ask, then you can talk.
Savita madam, please mute your mic. Savita madam, please mute your mic. Savita
Audience, please mute yourself so that there will be no disturbance to the others. Thank you. Thank you. So this is scientific method. You might have seen this diagram. These diagrams are available on the net there. Again, it comes where it is there, experimental data. This is the area where we are today following. And we are making with the available data. And then we are processing the data for hypothesis testing sometimes. This is there. So hypothesis testing is one of the part in the research. And then whether the hypothesis is yes or no, that is another outcome of our modeling there. Or in engineering method, okay. So this is again data, decision, prototyping, testing when we are getting. So developing prototype solution, testing the solution. So at this particular point, we need mathematical modeling. Okay, so that is the one of the purpose here why we are learning mathematical model. The data is available there, and we know that right from the beginning when we are learning or teaching to the engineering students, we are starting to teach from the engineering curves, and then different mathematics are there. And then we are coming to know that their applications are there. So suppose we are teaching gear, and then we come to know that the gear profile, why the gear profile is either involute or cycloid. So it has a mathematical base. So this is all experimentally done by Galileo, okay, in 13th century, and that video is also there. I can show you afterwards. And then he come to know when the marble is traveling through the straight line, and when it is traveling through the parabolic curve, and when it is traveling to the cycloidal curve. So what happens? The marble which is following cycloidal curve, it reaches faster than other two paths. Okay, this is experimentally evaluated. This is did by the experimentation, and then they come to know. So the curve which is used cycloidal, that is going to be used in the gear profile. So that is the experimental way and its application. But every time all the experimentation are not possible. So sometimes we have to use mathematics, and this is all mathematics done by Newton and Jacob. And then they found that why it is traveling faster than other curves, and the cycloid path is more preferred. So that's why you will see the efficiency of the gear transmission is more than other transmission mechanisms. So that is the beauty of mathematics. Mathematical modeling is there. So if you read Achyut Godbole's book of Ganiti, then you will find that there are a lot of such examples are given. So this is the one example. This is when we are teaching engineering curves, we don't know. These are the applications, and then what is the connection with mathematics and its application. You have seen in the civil engineering, somebody is in the civil engineering, you will come to know that the arches in the bridges, okay, what kind of curve they have. Anyone knows that? Okay, we will have some this interactive session. Otherwise, one-way communication without looking to anyone, so it is very difficult. So that so difficult. Anyone knows what is the application of curves there? You know the bridges. They are having that curves there. What kind of curve is used and why this curve is selected? Anyone knows that? Anyone from civil engineering background? Nowadays, we are, I think, Sangli and Kolhapur area is facing flood issues there. And typically, why water is not flowing. And if you see, normally new bridges, when they're constructing, they are using reverse cycloidal curve. Reverse cycloidal curve. So, why this reverse cycloidal curve? So all the forces they are concentrating at center point, and this is proved mathematically by Jacob. These are the applications of mathematics, and then that is going to be used for the practical applications in this engineering or mechanical. Suppose in electrical engineering is there and you want to connect two wires, and in the poles when you are hanging wires, okay, which curve is giving stability there? Which curve is giving stability to the curve? So that is again application of curves and mathematics there. So this is the mathematical modeling always going to help you for engineering applications. So this way, this research has its base there, and when we are teaching either this kind of topics there, so it going to, if you go behind it, you can find out there. Okay, this was just I'm telling you what we are learning has its connection there and how it is useful. Otherwise, there will be no difference in other graduates and engineering graduates. So mathematics is the only way it makes difference with other graduates, and it is proven by experiments also there. There is small difference in science graduates and engineering graduates that we are not going there because this is not our for today's topic. We are getting data now. Now data that is depend upon what kind of research methods you are using. So Kothari is one of the book, is a very good book if you want to start your research process, and that is still now it is one of the good book there. It is giving guidelines about research methodology. Earlier people, they doesn't know about how to carry out research work. Nowadays it becomes very simplified process. People are giving you this kind of workshops there, coursework is there, research methodology, then this all books there. Now they are talking about publications, citations. So all things are becoming familiar. The research graduates, research in the beginning only you are coming to know all these things. So that that kind of we were not fortunate when we started our research work. We were just doing a lot of here and there, and then we are just coming to the one path there. But nowadays it is very useful. A lot of techniques and guidance is available so that you can carry out your research very systematic way, and that is going to help you to complete your research work in 3 years or 3 to 4, 5 years. There are some administrative backlog are there, but still we can finish our work there. So data processing, yes, I would like to once again confirm about audio and video. Is it everything fine? Is it settled now? Hello.
Yes, sir. Audio is clear, but sir, the slide are not clear. They are blurred.
Okay, just we will see next slide now.
Yes, sir.
Now it is it okay.
Okay, it's clear.
It may be the problem of image there.
Oh, yes.
Okay. So the last slide was regarding data. So engineering research is either experimental or sometimes it's observational, especially the production or industrial engineering branch there. They can go there. Or marketing research, social research, they are coming here. And then there we can use analytical study, descriptive study, and then we can use various statistical tools and software. Suppose I want to test hypothesis, H-test, T-test, ANOVA, regression analysis, those are useful. Then when we are receiving the data, we should have exactly plan for mathematical modeling. Okay. And we sometimes saw that without a mathematical model, people are trying to, even this is necessary right from the PG, we should have to use mathematics in your dissertation work. So what is modeling now? It is an abstraction of reality. It is abstraction of real physical phenomena is converted into the reality. This is a representation of particular phenomena or idea or activity or condition. And the last sentence is important. It is never perfectly accurate. Okay, so there is always chance for improvement. Mathematical modeling is the art of, this is now a bookish definition of mathematical modeling, translating problems from an application area into tractable mathematical formulations, okay, here, whose theoretical and numerical analysis provides insight, answers, and guidance useful for originating the application. So this can be said as the, you can say, the definition for the mathematical modeling. We know that we use this process there. So it is a representation of real world problem in mathematical form. So suppose I am simply pushing a table there. I am pushing a table is just physical activity. So I am applying force. Table has a mass, and when it is moving, that is acceleration. So this is just a simple phenomena, real world problem that can be converted. So there are three parameters: force is there, mass is there, acceleration. So I must know what is the relation among between these three parameters. Okay. So what will make impact if I'm changing value of the one variable? Suppose mass is changing, then what will be its impact on acceleration and force? If the force is changing, other two parameters. So whether I want to move my table slow or fast, then what is the impact of mass and force? Like this. So this is the representation of real world problem in mathematical form with some simplified assumptions. Now this is important. There are every mathematical assumptions are there. When we are learning or teaching there, we know whenever we always starting with the writing assumptions. Suppose I am teaching bevel gear, so then I am making assumption this is a rectangular. Normally it is not a rectangular, but the assumptions are there. Or I am teaching Bernoulli's theorem or something there. So what are the assumptions? So in the beginning, assumptions are there. So if we want to make research there, so in the prior to the mathematical modeling, what are the assumptions are there that need to be clearly stated. So assumptions, limitations, scope, those are also important part need to be confirmed before mathematical modeling there. By mathematical modeling, you can understand fundamental and quantitative way the problem. The problem you can understand fundamental and quantitative way. It is complement to theory and experiments. Now this is okay. This is very important that it is complement to theory and experiment. So there are now in the upcoming slides. It is always there is one example is given there. How experimentally, analytically, numerically can be proved that how the results are there, and integration of theory and experiment is can be done by mathematical modeling. So Bernoulli's theorem states that the energy remains potential energy and other two energies they are constant. That is its theory, and the experimental also you are going to prove that. But unless the equation is there, whatever doing you are doing the experiment, what you are getting the data, you cannot put in that table and the equation. And after solving the equation, you are drawing the conclusion. So that is going to help you. What is the outcome of theory, whether theory is correct or not with the experiment. It is having widespread applications. This mathematical modeling having applications in all branches. Science, engineering, technology, biology, medicine, all the examples in the next slide you can see here. Now, what is mathematical modeling? You need to frame questions. You need to frame questions about a real world problem. Then you need to simplify the represent some real world entity in equations. These are the equations. And then now these three are important. There are variables, the things which are changing. Then parameters, the things which do not change, and functional form, that is the relation. So these are the three important characteristics of mathematical modeling. What is the purpose of modeling there? Modeling helps in answering specific questions, understanding problem better, and communicating with each other. Communicating to each other means others, who we are publishing the research. Now I'm in hope I will play one video that just giving you importance there. So this will break anatomy also, monotony also. Just give me whether video is visible or not. Yes.
No, sir. There is no video.
You can't see video?
Yes, we can't see video, sir.
Video is not visible?
No, sir, only link we can see. Just try to click the link once again, if possible. Once again, click on the link.
One second. One second. Actually, I thought it will be, we can see that. Yes, is it visible now?
It is visible now.
Audio?
Audio is not clear, but video is visible now.
Okay, audio is necessary because I need to find out whether yes, whether you can see both audio video.
Sir, video was paused.
Video is paused now. It is not operating. Only one slide we can see. Modeling the process, but the video is not running.
Okay.
Sir, I think we can go further, sir. Excluding the
Yes.
video, we can go further.
Okay. Okay, we'll try to make. I will come back to PPT.
PPT is visible now, sir. Can go further, sir.
Yeah. Yeah, should I try once again if possible? Yes, is it visible? Hello?
Screen is visible.
Some points were there. Is it visible now?
No, sir, I think we can exclude the video and we can go further. I think.
Okay, okay, okay.
Okay.
Okay. Well, actually, this was a small YouTube video there. It is available on the YouTube. That is giving you again brief about some of the steps there in the mathematical modeling there. So that I want to introduce about that. That's why I've selected that video. Okay. Then why mathematical modeling? So if you want to perform the experiments and to solve some problems there, real world problems, it may be risky or expensive and sometimes time consuming also. So mathematical modeling is going to help you in this solving real world problems. This is emerged as a powerful and indispensable tool for studying variety of problems in scientific research, product and process development in the manufacturing there. Also, it improves the quality of work and reduce the errors there. Errors and rework is reduced there. However, mathematical model is only complement. This should you remember that it does not replace the theory. This is very important. So research is important there. What is your theory? What you want to prove? Mathematical model is only tool is going to prove your theory. Okay, so it is just it's supplementary, and you cannot replace theory and experimentation in research. Okay, this is the important message there. But this is you cannot exclude mathematical modeling. Performing experiment to understand and real world problems, it involves some risk and cost also. So mathematical model is the resource in such situation to avoid risk and make you can say cost cutting. So suppose I want to find out the testing of automotives now. So there is no need to now crush any vehicle. Okay, so with the help of mathematical models, numerical analysis can be done, and you can find out crash testing. Use of mathematics in solving real-world problems has become widespread, especially due to the increased computational power. Okay, so what now we know, the computers has enhanced its capacity, and the computational power is now really fast, and large power is available by means of evaluation of the computers, and that can handle the length and length and breadth of the complicated problems. Okay, so that is another advantage of mathematical modeling. So why mathematical modeling is there? It is indispensable in many applications. It is very successful tool in many mathematical applications. It is proven that.
Hello, sir. Sorry to interrupt you.
And direction for,
Still, it is showing the slide of video, sir.
sorry, what happened now?
It is showing the slide of video,
Oh, sorry.
link of video. Yes, sir.
I don't. Yes. Okay, just give the feedback again. It is I'm not getting idea whether I'm in the same slide or not. Okay, is it visible now? Why mathematical modeling?
Yes, sir.
Okay, then I will
Please,
not.
sir, switch on to presentation mode.
That's why I switched there, but I don't know why it is not moving ahead. Now, is it the slide is
Not yet, sir.
changing?
Slide is visible, but it is not in presentation mode.
Yeah, its presentation mode is there already. I did it. Check now. And now I am the slide. Why mathematical modeling? Are you having same slide?
Yes, sir. Same slide.
Okay. The another way is there. I can log in by mobile and I will check there. But I don't know whether. Okay. Can you see now why mathematical?
Yes, sir. This slide is visible. Why mathematical modeling?
Okay. Okay. So it is giving precise and accurate results and action for problem solving. It enables a thorough understanding. Okay, now one thing is that we can Yes, I was trying to find out from the mobile what you can see. But still not in the presentation mode, no?
Yes, sir, it is not.
In the slideshow model
Sir,
you can see.
excuse me, sir. As you share the PDF file last time, you are
Yeah.
sharing the PDF. Then you can share the PDF, sir. Then we can get.
Okay.
Okay, sir. It's visible. Please try to change that slide. Yes, sir. It's now changing.
Okay. Okay. Now I think we will go ahead here. Okay. So right now, why mathematical modeling? Am I on the same slide or I am on the next model there?
Yes, sir, it is showing mathematical model.
Okay. So it is giving me the points here why mathematical modeling is there. It prepares better design control over the system, allows the effective use of modern computing capability. Use softwares and computers for that. Okay. Mathematical model block diagram is shown here. I don't know whether it is a blur image or that. The first yellow box is real world problem. The modeling, it makes mathematical model. Then if you go to the problem solving some equation and tool there software, then you are coming to the solution. And then you are getting some charts and graphs. That is the interpretation. And that can be validated through the experimentation. You can explain what about outcomes there. So this is the cycle of mathematical model. Okay, now I'm coming to the next slide, good models. Is it visible now?
Yes, sir.
Hello. Okay. Yes, so good model should be simple. It have clearly defined questions there. Then it should be adaptable. I can use that. It's reproducible. Many times, whenever we are doing literature survey, we can find mathematical equations and models there. So, if you adopt these equations and if you reproduce the same thing there, then it should give very close result whatever he claimed there. So that is another sign of good model. So that is also required whenever we are producing. So whenever we are going for publishing, people, they find out they are putting the evaluators, they are using some values there, and they are solving these your equations, and they are finding out whether it is giving similar results. You need to clearly define variables. The variables must be clearly defined there. Okay. So simple example, we are continuing with that. So F means force, M is the mass, and acceleration, that is meter per second square, mass is in kg, force is in Newton, like this. We should have to define that. Now validation, okay, that is it should be, the model should be validated. Okay, it should be get validated. That is another requirement of good model. So you can validate with numerical. Analytical model can be validated with numerical model or experimental model. You can interpret results with questions. Okay, this we can with the help of model there. So this is just diagram slide here. Then use of mathematical model. Okay. It can be used to handle large scale and complicated problems. 1 second. And then these are some of the areas. All the next slides, they are giving a particular area and some of the examples there. So mathematical model not only useful for the engineering, the purpose is that I am giving you different area and we can find out engineering applications in that particular area. Anthropology is there, so that science of modeling, classifying, reconstructing skulls. This is about we can make a mathematical model. Archaeology is there, reconstruction of object from preserved fragments. So you can find out the age there of the various temples. So they are finding out when it is going to be constructed, like this. Then classifying ancient artifacts like this. So Kedarnath the temple is there. So they by looking, they are testing with the help of mathematical model, and they can go behind and find when it is going to be constructed. Architectural uses are there. Virtual reality, artificial intelligence, computer vision, image interpretation. These are some of the, again, mathematical model outcomes are there. Robotics, speech recognition, these are also some of the areas. Then optical character recognition, this is the physics. You can see reasoning under uncertainty. These are some of the areas you can find in the animation. So all these, you can see the movies on cartoon games. Now they are using one movie name is given here, Jurassic Park, for your just understanding. There are other movies are also there. So these are with the help of when they are creating animation, there is some mathematics behind it. Astronomy is there, planetary system. Okay, we know this is all based on the mathematics, but the Newton's laws now it is starting there, and that is going to help us to find out, explore about the planetary system. We are going to Mars and other planets and finding out how a situation is there. Correcting the Hubble telescope, origin of the universe, evolution of stars. Okay, these are all things can be possible with the mathematical modeling. In biology also there is, normally we feel what is the role of biology there. What is the role of maths in biology? What is the combination there? So this is one example, protein folding you can find in various foods. Human genome projects, there are also applications you will find of mathematics. Then dynamics morphogenesis is one of the area. Then you can also find out in the pandemic conditions now, corona is there, or what are the disease, so how that can spread, that can determined, or you can say judgments are based on the mathematical models. Then animal and plant breeding, genetic variability, this is can be possible with the mathematical model. So, you know, this in MATLAB various rules are there. Chemical engineering, chemical equilibrium, chemical reaction, dynamics of molecular modeling. Okay. These are some of the areas. This is particularly purpose behind giving that, so the people who are listening from the different disciplines, they may find out what are the probable areas. That's why these all applications are included. Normally, we can think that how mathematics is connection with my research. So some of there may be possible, the attendees maybe belong to the different disciplines, so they can relate your problem in such a way that, so they should imbibe mathematical model. We know computer science, there are a lot of applications. Engineering is, yeah, application of mathematics, we know. Physics and mathematics is largely, you can say, application of engineering. So computer graphics, then criminalistic science, fingerprint recognition. Okay, that is now everybody in day-to-day, we are using biometrics. So that is a pattern recognition. So it's giving you who is the person there. Okay, they are matching your fingerprints, and then it will recognize who is the person. So that way attendance is going to be marked now. No need of signing. Face recognition is also part of that. Okay. Electrical engineering, stability of electric circuits, microchip analysis, power supply network optimization. Okay, that PCB, yes, this is all mathematics is there. Material science, microstructure, semiconductor modeling, and mechanical engineering. Normally, people, as we are, this is conducted by program mechanical engineering. So there are a lot of applications. Stability of structures, structure optimization, crash simulation, value estimation, fluid mechanics, computational fluid dynamics, wind tunnel turbulence. Okay. So these are some of the application. So there also people used by the various people. Now CFD is used by Michael Phelps. Michael Phelps is the only one, I think, the one player who won more than 23 gold medal in Olympics. So we know that Olympics is going on there, and they are enhancing to his performance. They use CFD, computational fluid dynamics techniques. So how the actions is there, how minimum resistance is there, how the body suit, where is body posture. So everything they are designing. So they are taking help of this software. So now, because they have to improve the performance by 1 second also, that is becoming more important in this cutthroat competition. So that's why when they are, when he is swimming, they are making his analysis and it is analyzed in CFD software, and then they are minimizing the resistance, okay, when he's swimming, and that is going to help him to enhance his performance. So this way, this is going to the actual real world problems. Mathematics is going to help us. There is also application in medicine, economics. Okay, economics is their labor data analysis, financial risk analysis. Shares also they are using largely various mathematical tools there, and there are various softwares are nowadays available. With the help of that, people are investing their money. Political science. Okay, you know the last election in USA happened with the data analysis. Trump and his someone opponent. I don't remember right now, but so what is the trend is going right now? So how to change the trend? So that they use data analysis tools and techniques, and they have helped us to contest in the elections. Then meteorology, climate prediction, global warming, okay, weather prediction. This is we know now how much it is important. So music analysis, this is there. Neuroscience, these are all the areas are there. So mathematical model find mass of the earth. Okay, we know even Aryabhatta, he found that what is the rotation time Earth required, that is 365.24 days. So how he found that? That is the base of mathematics. Okay, so in that age also in 7th century there, he found out that how we can calculate the time required for rotation of Earth around the sun. So that is the beauty of mathematics. So you are at your own place. You don't need to go with a watch and calculate. Find the temperature of center of the sun. So you don't need thermometer there, but you can predict the center of the sun temperature. You can find what is the volume of blood inside the body of a person. Okay, there is no need of bleeding the person to the death to count that volume. You can estimate the population of India in 2050. So you don't need to wait up to 2050. You can estimate the total expenditure and of an owner to run any garden, okay, for any farm for the next 5 years. So this is a DOE, design of experiment, you know that. So you can find out how much the expenditure. So these are the applications. Okay. Now we are coming to the modeling stage. This is what is modeling, why modeling, and what are its application area. Okay, any questions here? Yeah, audio video is clear?
Yes, sir.
Okay. So particular, this was a base for mathematical modeling there. How it useful and why mathematical modeling should be done. Anyone have questions? You can ask now. We will go ahead. Yeah. Yes, audience, would you like to ask something?
If any participant is having question, then they can ask before moving forward.
Okay. So should we go ahead now? Next. Again, I lost you. This is avoid mirroring. Don't share your entire screen or browser. Just okay. Again, I lost the screen there. Okay. Yes, I'm back there on the slide. Main steps. Is it visible to you all?
Yes, sir.
Hello.
Yes, sir.
3 main
Okay.
steps slide is visible, sir.
Okay. So in the modeling, there are 3 main steps: modeling, formulation, solution, evaluation. So these are the 3 main steps for mathematical model. Stating with identifying mathematical question relevant to the factors. So that is the beginning point of mathematical modeling. Yes, is it moving to the next slide? So mathematical model follows the process. Yes, you are getting same slide. Mathematical model follows the process, right?
Yes, sir.
Okay. To start formulation of model, okay. So you need equation, the solution, evaluation, and whether yes or no, and then you have to find out whether our model is successful or not. Some lag is there. Mathematical models are basically of two kinds, two types are there: empirical models and theoretical models. Empirical models based on the observations. So this is typically the marketing problems or societal problems. They are uh, sociology or others. They are based on the empirical models. Survey based, industrial engineering people. So when they are going to enhance their which factor is making impact on the productivity like this. So there is empirical models are there. Theoretical models are also there. Sorry, this is observational mathematics. Empirical model means observation. So when we are doing the experiment and getting the observation, those are empirical models. And theoretical models, those are like statistical models, survey-based models. So in the last 3-4 decades, its importance is now growing. The statistical tools, earlier it was very difficult to use various statistical equations, and very large data is there, and handling this large data was very difficult. Okay, and there were many errors maybe possible, but by means of evaluation in the computers and softwares, so this statistical data processing, that is going to become very familiar, and now it has become very big. So big data, data analysis, these all tools or techniques are nowadays available, okay, to handle large data. So statistical, mathematical, and computational, these are the different type of models are there. Now there are some complex social systems are there. A system is set to elements and relations. So this is for establishing mathematical model there. Complex system is a system whose behavior cannot be easily predicted. So that called as complex system there. So we know that. So when it is going input 5 and coming output 3, so I don't know what is happening. So that was a complex system there. Social system is a collection of individual and interaction. The complex social system, we can say, whose behavior is primarily the result of behavior of individuals. So that is a complex social system is there. Social system is a collection of individual and interaction. This is all type of people who are belong to the other than engineering area. For them it is useful there. Or this can be variable when we are making a model as a different entity. That time also it is becoming important. Suppose the parameters which are making impact on productivity, these may be individual parameters, then can cluster of parameters, system that can be also there. So that way the complex social system can be generated with the help of mathematical model. So this is the block diagram of modeling process: conceptual modeling, mathematical modeling. So all the equations are coming here. And then computational modeling, so we have to write a program and then input the values and it needs to be get solved there. So these things are coming in the modeling process there. So this is again going back to the closed loop system there, and we can validate the results. This is a SIR epidemic model. Now, this is in whenever there is a spread of pandemic, and in this pandemic conditions also, this kind of model is also used there. So people are nowadays, they are talking, there will be second wave is coming, third wave will come like in this period. So how they can say about that? Normally we hear such kind of news there. You are, if you refer the newspaper or in the televisions, the news is coming there. The people are saying the third wave will come in August of this year. Okay. So on what basis they are saying? How people, normally the question is coming in our mind, how they can say it will come in August? Why not in September or November, or why not in July? Okay. So there are some models are there, and based on that, the data which is available, and some model after the processing, they can say that they are coming with some inference, and that results. Then they are talking like this. So probable period of third wave of corona pandemic will be in the mid-August, like this. So this is called a SIR model. So S means susceptibles, the individual susceptible to the diseases. Then infectious, the infected individuals able to transmit the parasite to the others. Then recovered, the individuals that have recovered are immune or have died. Okay, so from the disease and do not contribute to the transmission of disease. Okay, so that is if the death is occur now here, so then he will not transmit disease to the other. So this is called conceptual model. Yes, SIR, susceptible infection. So there, this is again the model which is including deaths. Okay, so individuals that have died from the diseases. Okay, this is conceptual model there, and they are saying here recovered, and then died. Okay, they are taking this parameter. So this is the conceptual modeling. This is the first step there. Okay, the modeling process. When we were talking there, in the 3 steps there. The first step was the conceptual modeling. Conceptual modeling is here. So that is the example. The first step is here. Okay. You can see here. Yeah, if it is, the tool is available for highlighting it. Now the mathematical modeling, next step comes there. Okay, am I on the same slide? What you can, you are viewing, you can see that. Hello.
Yes, sir.
Yes, sir, same slide.
Same slide. Okay. Okay. Now, conceptual model is the first part of it. Then why? The next is the mathematical modeling. Now, this is the same diagram is taken here, and then it can be transferred to the mathematical model. So there is some equation will come. So this plus minus equal to something is coming. So in that diagram, if it is coming, so 5 minus 3 into time interval. So if we add 2, then it will result in 300. Or it can be again made so complicated, 5 minus 3% of x into t minus 1. So that can be equation. That is the mathematical model. We can say conceptual model to conversion to the mathematical model. So that is the difference between the different conceptual model to mathematical model. So this can be a simple equation. It can be like this equation also there. So conceptual modeling to mathematical modeling, again, then we are going to the computational modeling. Then that is the part every researcher has to contribute now. Okay, so this conceptual model, so according to your research topic there, so first you need to prepare a computational model, then mathematical model some is there, and then computational model. Anybody want to talk about computational model? What do you mean by computational model? It is becoming one-way communication, so little bit we will have discussions so that uh, it will become interactive session. Otherwise, somebody will just log in and they will, okay. So, what do you mean by computational model? Anyone knows? Because we are very familiar with this, so that's why. Not that much difficult question. Any example of computational model?
So it is a in computational modeling we are using
Sorry, it is not audible to me. I don't know. It was not audible to me. What about others? I didn't.
computational modeling in this we are using the computers to simulate.
Yeah. Okay. Any one example you can go ahead, we can discuss there, and then we can understand how it can be used in the research process. Anyone belong to the electronics or computer discipline there? Hello.
Hello, good morning, sir.
Yes.
Yes, sir. Computational science is completely based on a computer and mathematical related thing.
Yeah. So any one example you
Refers to
can
a
like to
computer
quote?
performs simulations.
Yes.
Yeah, numerical analysis.
Yes. Numerical analysis is there. Yeah. Suppose you are using any tool there, but for time being, consider you are using MATLAB there. Okay. So any example you would like to quote here?
Finite element methods.
Numerical methods are there.
Mathematical finite
Yeah.
element methods, finite difference method.
Very good. Very good. Yes. Suppose plant layout is there. I want to optimize there. Okay. So there are some different tools and techniques are available. Okay. So genetic algorithm is there is okay. There is a lot of optimization techniques are there. So these all are coming here in the computational modeling. So which tool is more useful? That you need to find out. So you might have attended various workshops there. Okay, so use of different optimization techniques there. Which optimization, one of the optimization technique mechanical engineering people used to do prior to the optimization there. So suppose there are 3 to some 5, 6 parameters are there, and they have 3 variables values are there. And if you want to use do the experimentation, then it will go very long there. So prior to that, if you use some optimization techniques, they can optimize, and which is giving the better results. These are 9 to or 27 something experiments are coming there, so that we can perform, and then we can validate the results. So this is coming as computational modeling here. Okay, so that way it can be used, and this is the main crux of your research work. Okay. So it is leading from conceptual modeling to mathematical model, from mathematical model to when you are coming to the computational model. This is the core work. This is the core work you are doing. So how accurate you are doing, that is the making impact on your outcomes. Okay. So which method need to be selected, and what kind of tool you are going to be used. So these all earlier steps are going to help you there. So which best method suitable is there, and then the outcome of this model. Okay, so that is going to be interpreted. The interpretation coming out from this computational model, these are published as results and conclusion there, and that is going to help your research outcomes there. This is conceptual modeling diagram. I think the slide is got repeat. Okay. Computational modeling, yes. There is simulation and visualization, right? So that's why I involved you people there. So you will also feel that you are going on the right track. So computational modeling is simulation. There is simulation or visualization. So simulation is technique for analyzing, designing, and operating complex systems. Okay. So now all the engineers are here, so they are very familiar. If the people belong to the other disciplines now, we need to explain this particular phenomena in detail there. Visualization is any technique for creating images, diagrams, and animation, communicate the behavior, describe the behavior of the complex. This kind of also people are doing some experimentation, visualization. Okay, so there are certain tools are there, or actual experimentation you can go ahead. Am I moving the same diagram again? Okay. Then what are the different type of models? So these are 6 here enlisted, but this is not only 6 there. There are others maybe there. Which are the most commonly required? These models are here right now. Okay. Static or dynamic. This is the first one. Discrete or continuous. This is second type. Third is deterministic or probabilistic. Linear and non-linear. This all is very familiar with all the engineering peoples. Explicit and implicit. Okay. Qualitative and quantitative. Okay. So this is okay, one here. Static and dynamic model. Okay, now what I can say, the first is static and dynamic model. Okay, we know that this is very well known to us. Static model calculates the system equilibrium, but it is time invariant. Static model cannot be changed. No one can edit the mode of static model. That is the static. We know that. What is the static condition and dynamic condition? The dynamic model accounts time-dependent changes. So crash analysis, what we are doing. So what we are doing now, suppose designing of car is there. So what are the forces acting there? We are finding out stress analysis. This is the static model. And if I want to do the crash analysis, then I need to give the velocity to the model, the car model I prepared, and it has to get crushed. It has to have impact on some wall there. And then I will find out what will be the, after crushing, what will be the changes. Okay. So that is the dynamic model. So this is a simple example. You all may be very well aware about that. So dynamic model refers to the system changes over the time. The static model refers to the system that is steady state. Dynamic model is a representation of behavior of static components of the system. Then continuous and discrete. Continuous and discrete now. Okay, this is again our many problems may be subjected there. Okay. Anyone knows any example of continuous and discrete models? What is meant by discrete models? Discrete models at countable numbers. Continuous model, variables change in the continuous way. Okay, the fluid mechanics problems. Normally, I belong to the mechanical, so some of the examples I may quote which are related to the mechanical. Other discipline peoples, they can add here. Okay, this continuous and discrete in the electrical and computer engineering field, there are a lot of examples are there. So discrete model treats object as a discrete. Suppose the particle of molecular model, that is a discrete model. Discrete model treats object as a discrete. Okay. Clock is an example of discrete model. Clock is an example of discrete model because the clock keeps the next event start time as simulation proceeds. Okay, this is one example to understand where we can, as per your research, which model is suitable. That's why we are discussing that. Continuous model means which represents object in continuous mode, like the velocity of fluid in the pipe or channel, temperature in the heat transfer model, temperatures, or in the electric field, magnetic field, that is also called as the continuous model. So discrete model and continuous model. Okay, now the next is a deterministic and stochastic model. Deterministic model, there is no uncertain components, no parameters are characterized by probability. Okay. Anyone want to talk about this, which is deterministic and probabilistic? This is all application oriented and we are coming every day across such examples. So if you give the examples, it is better for understanding to everyone. Okay, so anybody would like to contribute here? Because it is becoming one way. I don't know. I'm just feeling that I'm talking to the box like this. So that's why I want to include you all here. In the deterministic model, every set of variable is uniquely determined by parameters. There is no variation. The deterministic model describes behavior on the basis of some physical law there. That is the deterministic. And stochastic means probabilistic. It is another name is called probabilistic model. Okay, so probabilistic model. So the corona pandemic condition now, this is all probable. We don't know. weather prediction. These are all probabilistic models. So where exact prediction is not possible. Okay, so there is randomness is present. Okay, and there are variable states are there. So that is called as probabilistic or stochastic models. Okay, this is another. The next is linear and non-linear models. Linear and non-linear models. Okay. This is, I think, very familiar example. I can expect from now the participants, you can talk about that linear and non-linear. Yes. Stress is proportional to the strain. Okay, that is linear model up to the, okay, where up to now. This is a common example. When we are learning material science, we know that. Yes, any other example? Any example of non-linear? Linear is okay. Hello. Oh, so if it is interactive, then okay, what will happen? We can understand more better. Now, nonlinear model, we know in the same stress strain curve there, what happens now, strain is not proportional to the stress above Hooke's law, okay. So that is becoming nonlinear. So the dependent parameters is not varying according to the changes, on input parameters. So nonlinear model introduce dependent parameters that are allowed to vary throughout the simulation run, and its use become necessary when interdependency between parameters cannot be considered. Now there is interdependency is not necessary to consider that. So what is the impact of stress? Now this is not going to be considered. Now we are going to the material behavior theory there. So that is the nonlinear models are there. Okay, so this is linear and nonlinear model can be there. This is also can be applied in epidemic conditions there. Aggregate and individual model and aggregate. Individual model we know. Aggregate means suppose I want to find out impact of the productivity parameters, different productivity parameters. So either maybe in the manufacturing from the design, okay, or some the market situation problems are there. So how they are making impact, psychological parameters, workers, these parameters, how they are making impact on. So these are the aggregate parameters. So the total parameter is going to making impact on the performance, the productivity. Okay. Qualitative and quantitative. Okay, this is now I think very well known to you. Qualitative and quantitative. Okay. Yes. Quantitative means okay, that is going to be countable, numerical prediction. Okay. Qualitative models to generate descriptions about the responses. So these are the feelings. So suppose car model is there and you are finding out customer experiences when they are using this particular car model or bike model. So they are giving qualitative responses. These are not quantitative. Okay, these are qualitative. They will, okay, they are talking about their feeling. very good, very comfortable. I like it, very nice, like this. So these are all models. These are giving responses in qualitatives, and quantitatives are there giving you in the numbers there. Okay, so there will be some numbers are there. So if 1 to 5 scale, how much number you will give? 3, 4. In the feedback analysis, the people are giving numbers there. So there is correlation between qualitative and quantitative there you will find. So in that same, people are thinking that they are making correlation between qualitative and quantitative, and then we can get these models. Okay, now we are coming to the next part. Is there one example of linear analysis there? So this is one example. Okay, so should we have a break or how? Because now I think it is almost 1 hour. So there is one example is there, linear analysis, how the mathematical model is used, and one example about non-linear analysis there.
Sir, the time is running out, so you can take that particular example and then we can complete.
Okay. Okay. Yes, this is mathematical modeling and how the particular one example with the example, same things are given here. Every part requires some mathematical modeling and background. So this is one equation. Roots of this equation, if you solve f of x, then algebraic equations, then you can find these solutions. Then interpolation, that we are used that all this regression. So interpolation we use in the fatigue loading in mechanical peoples. They are using there to find out life of the bearing there. Integration, area under the curve. Okay, like this. Then these are the ordinary differential equations to find out the slope there. Computers are great tools, however, without fundamental understanding of engineering problem, they are useless. Okay. Simulation you can do in finite element analysis, computational fluid dynamics, molecular dynamics, particle physics, earthquake simulations. These are the benefits: cost saving, increased speed of market to bring reduce product development time, optimize structural performance, eliminate expensive trial and error. Now this is again all crux of that what we learn. Problem definition, mathematical model, you need theory and data here. Problem solving tools, what we need: computer, statistical, numerical methods, graphics. So model is here. Then interferences, scheduling, optimization, that are the about coming in the implementation. So this is all crux of what we learn there in summary there. Now one example is here. So it is simple phenomena, physical phenomena, how can be converted in analytical and numerical model. It is giving you example. So Newton's second law of motion, we know force is equal to mass into acceleration. So the time rate changes for the momentum of body is equal to the resulting force acting on it. So F is the net force, mass, this is all conceptual model now, mass of the object, acceleration. Suppose some complex models to require for more sophisticated mathematical techniques, then we can say F is equal to Fd plus Fu, where Fd is the force due to gravity and Fu is force due to air resistance. Now this is, you can consider here when the person is falling from the parachute there. Or suppose you want to design a drone also there, you need to consider air resistance and all this. This is total summation of force you can consider here. The falling parachute, this is one example. Now how the mathematical model is created and how its numerical solution is done and can be experimentally done, it is explained in the coming slide. So this we know the equation dv by dt is equal to f upon m. F is, we know the combination of FD plus FV, drag force and the resistance here, gravity and this. The gravity force is m into g, and the air resistance is minus CV because in the opposite direction. Okay, so C is the drag coefficient here. So dV by dt can be written, if F is there, mg minus CV by m. So this can be written as dV by dt is equal to g minus c by m into v. So this is the first order differential equation we would like to solve for the velocity. Analytical solution now, if the parachute is initially at rest, when it is we are dropping, the velocity is 0 and time interval is 0. So using calculus dV by dt, you can solve the results here. Now this mathematical variable is described here. This is dependent variable. This is the forcing function, and this is the parameter, which is the independent variable. This independent variable making impact on dependent variable. So this is conceptual model. We are now learning conceptual model. So here is the analytical solution. If g is 9.8 meter per second square. Now this equation, when we are plotting, then that is the mathematical model. So v with respect to time, that time at particular interval, this cannot be solved analytically. We need to use some numerical method, and that is the equation here. The values are here. C is the drag coefficient 12.5. M is 68.1 kg if the mass of that whole person and parachute considered. So if you put this value at t is equal to 0, v is equal to 0. When time second is 2, for the now 2 second duration, interval of 2 seconds now, velocity is 16.4. At 4, this is go on increasing like that. And you can plot its results now. So this is on the x-axis t, and this is the velocity, and by getting this value you can draw this graph. So this is an analytical solution. We know that it is a very simple way. Already you have done a lot of kind of these problems there. So this is changing the velocity with respect to time. Okay, this is all numerical solutions. So this equation is arranged there, and you can find out. To minimize the error, you can use small steps. Okay. So this is the true step and small step. More inferences are calculated. Okay. So analytic versus numerical solutions now. Now this is solution we got by mathematical equations. So 2, 4, 8 there. The numerical solutions you can find by using some computer technique. This is called computational model. Now this earlier was what we were discussing. This is called computational model. This is called computational model. So using this equation, you can compute their values, and you will get by the results which are getting by the numericals, the software results. These are called numerical solutions. Now when these numerical results are there at the time interval of 2 seconds, you can see the results which are plotted for different time values 2, 4, 6, 8. Now again, if you use time interval of 5, you will find these values, and the last is 0.01 second. Now you can see the analytical results, and now the interval is very small, 0.01 second. Now this is more accurate. It's that the results coming from the software or computer using, they are more accurate. But now if you see this example, you will find out that they are not that much accurate here. Our analytical results, they are matched when the time interval is very small. So you are minimizing the error here. So analytical and numerical, this is the mathematical model, analytical model, and then numerical model is in the earlier slide. So if you want to minimize the error, use smaller step. So this is the analytical model here, and this is the numerical solution here. Using MATLAB code, you can find out the results, and you can validate that. So they will find out that analytical model and numerical model. And then we can do the practical experimentation, and you can find out the correlation between analytical results, numerical results, and actual experimental results. So that is going to help you. So prior to the doing all experimentation, now you don't need to jump from the helicopter with parachute. We can find out the velocity at different times. What will be the when you are dropping down there? So what will be the velocities there? Okay, now this model will not work there. Then one example of nonlinear analysis is again given beyond the elastic limit. So, sir, should I wind up now? Some glimpse I will give about nonlinear analysis and sensitivity analysis and asymptotic analysis, which are the part of. Okay.
You can use some links. Yes, sir. You can use some links, and your PowerPoint also is going to circulate among the participants. So if required further, can contact you in future.
Okay. Okay. So nonlinear analysis using FEM that is given here. Nonlinear analysis. Okay, in the structural guidelines. So this is the linear response and nonlinear response, where what we were talking about earlier, linear model and nonlinear model. So these are already, we are familiar with this curve there. So this is the calculated responses normally coming, and experimental results are coming like this. So this difference is called error. So the error accumulate with each load increment, causing that which the results are going to the out of the some of the curves there. So what is the when wherever you are conducting non-linear analysis is to apply the load gradually by dividing it into series of increments. So whenever you are doing the non-linear analysis, you should do a series of increments so that you will get better results. Okay, so here it is the step made incremental 1, 2, 3, 4, 5. And this is giving now the analysis done on the using ANSYS software, because it uses Newton-Raphson algorithm, and it applies load gradually in increments and performs equilibrium iterations for each load increment, and this solves these equations. So stiffness matrix, displacement increment, and load vector, and this is plotting the retrace. So this iteration continues there, and the graphs will be generated. So the process is repeated for each load increment until the full external load is applied. So it involves following things: one or more load step, apply external and boundary conditions. Multiple sub-steps can be implemented there, and it can be equilibrium iterations obtained after the each sub-steps there. So the combined curve you can see like this. Okay, these are the time increments. So this way you can perform the nonlinear analysis for better understanding. Now there are other two techniques. One is called asymptotic analysis, and because there are some errors in mathematical modeling and experimental like this. So asymptotic analysis, sensitivity analysis, these are the some of the part of error analysis is required, which should researchers should familiar for this. So in asymptotic analysis, we evaluate the performance of algorithm. Especially this is useful for electronics and computer people. This is also used in the share market softwares there. In terms of the input size, it calculates how does the time taken for algorithm. Okay. So there are few examples are available. So this is asymptotic analysis is very important. Heat transfer problem also, sensitivity analysis and asymptotic analysis. These are the one of the error consideration. Always the examiner will ask about this. Okay. We are not sensitivity analysis. I will go now. It is called as what if analysis. Sensitivity analysis is the assessment of impact for output of the system by changing the input. Okay, this is one. If these variables deviate from the expectation, what will be the effect? This can be on the business. These are the few examples. Model system like this, they can be used here. This sensitivity analysis can be done, partial sensitivity analysis, best cause, worst cause, like this, you can make it there. This is very simple. Okay, this is giving direction to the management. It can be automated also. This is another disadvantage is it is not giving clear-cut results, but not standalone solutions. Okay. Okay, these are the some of the fun that at the last we should have that. This is after the research experiments, definitely is something is happening. So research method is saying that why these belt signs are having turning. Okay. Now this is about, we are worried about publications. I already wrote a paper. Okay. So that's why, okay, the paper publication part is there rather than research. Okay. And these are some funds for you. At the end there, you to make your mood, you should not get bored here. So according to this news, polls, 93% American people believes that polls have no statistical validity like this. Many times they are making polls outcomes there. So exit poll results, and these are. Okay. Okay, this is about statics. Mirror on the wall, who's the fairest of them all. Okay. So in my demographic, graduated on the curve. Okay, these are based on the curve there. Okay, so I'm not feeling, nobody's yawning now, and it's somewhat good addition there. Okay, so this is about the mathematical model and analysis and some error analysis, errors consideration. Okay, this is in from my side. You can have some questions you want to discuss. We can discuss now. Hello.
Participant can ask the question if any queries are there. Participant can ask. You can mute your mic. You can ask the question.
Yes, this is the important part of our whole research, because this is giving you the outcomes are based on this only work there. The deciding tool is very important.
Right. Shenge sir, if the participants are interested, they can ask any query.
Any participant, if you having any question, then you can ask.
We are providing PPT also to you and the mail ID of the Dr. Kothavale sir. Afterwards, you can contact any query.
Okay.
Okay.
Chinggir sir, you can proceed now.
Okay, sir. Thank you, sir. Today, Dr. Kothavale, sir, has
One
conducted.
second, sir. Mr. Abhishek, you want to talk, I think. He has unmuted his mic. Mr. Abhishek, you want to talk something?
Okay. Any question?
Mr. Abhishek, he has unmuted his mic. That's why I thought that you want to ask something. Mr. Abhishek?
I think you got very good response. More than 140 participants were present there.
Yes, sir.
Very good response.
Okay. Thank you, sir. Today, Dr. Kothavale, sir, from MIT World Peace University, Pune, has conducted a very good and informative session on data processing, mathematical modeling and analysis. He has explained different types of the mathematical modeling with the example. I hope this session will be beneficial for our participants for their research work. On behalf of our department, Mechanical Engineering, from our institute, Nanasaheb Mahadik College of Engineering, I would like to express my vote of thanks to Dr. Kothavale sir for accepting our invitation and conducting today's session. Thank you, sir. I would like to express my vote of thanks to our head of department, our principal, Dr. Mirje sir, our executive director, Mahesh Joshi sir, our secretary, Rahul Dada Mahadik, for giving us opportunity and for encouraging us to conduct such programs. I would like to express my vote of thanks to my colleague faculties for their cooperation for conducting this workshop, and I would like to express the vote of thanks to all our participants for their huge response. Thank you. Thank you very much. Now,
Tomorrow's announcement. Yes, sir.
yes, sir. There is one announcement. The session, that is the session, fourth session of 29th July 2021 will start exactly at 1 p.m. Due to some technical problem, we are postponing this session. But the day is same, that is 29th of July. Just we are starting the session at 1 p.m. The further notification we will post on our WhatsApp group, and feedback link of today's session also will post on WhatsApp group. Okay, thank you all.
1 second. 1 second. I will talk 1 second. Thank you, Dr. Kothavale sir, for your contribution in our FDP. It's a very good session, and your PowerPoint presentation is very good. And thank you very much for your contribution.
Thank you, sir. Thank you to everyone. Thank you for giving the opportunity to me.
Okay, sir.
Thank you, sir.
Thank you, sir. Okay.
So should I
Now
log
I
off
would
now?
like. Yes, sir. Now I will announce that the session is over. Thank you all.
Sir, can you please share the PPT?
Hello.
Can you please share the PPT, sir?
Yes, sir. Yes, sir.
Yeah. Please share the PPT on the group, sir.
Okay, sir.